what percent of the data lies between, 85 and 115 if we know the mean is 100 and the standard deviation is 15? Well, what if the mean is 100, the standard deviation is 15, and I want to know what percent of the data lies below 105? That's not, I can't use the empirical rule to answer that. We have one standard deviation away from the mean here, the mean's in the middle. 105 is somewhere right here in between 0 and 1 standard deviations from the mean. So we're looking what percent, or what's the probability of randomly selecting a data point and having it be below 105. What's that area, or what's that percent? What's that proportion? By the way, that's all asking the same thing. And there are a couple of ways to do this. And in the homework, it tells you either use a table or use technology. All right, so if I go ahead and open up Statcato, I'm going to go to Calculate, Probability Distributions, Normal. And if I leave the mean as 0 and the standard deviation as 1, that's the standard normal curve. I want to click on Cumulative Probability, and that will calculate the area, the total area. If I click 0 and click Compute, it's going to give me the normal distribution with the mean of 0, standard deviation of 1. If I input 0, the probability that x is less than or equal to 0 is 0.5. Now that totally makes sense if we look at the standard normal distribution. I can just type in normal distribution calculator also on the web. I'll click on the first one here. Looks like David Lane made a nice one. And again, here we have the mean is 0, the standard deviation is 1, and I want to find the area below 0. And again, it's giving me 1/2. That makes sense. 0 standard deviations above or below the mean is right in the middle. It is the mean. 0 standard deviations above or below the mean means it is the mean, and the area to the left of the mean in the normal curve is 50%. The area above 0 in the normal curve is also 50%. But that's not what we wanted to do. We wanted to find the percent of the data that lies below 105. So here's what we're going to do. Again, I'll go to Calculate Probability Distributions, Normal. I could do this two ways. I could use a z-score, or I could input the mean and standard deviation. So first I'll do it just the easiest route, which is input the mean of 100, standard deviation of 15. Those were given. I want to do a cumulative probability and a constant of 105. I want to find the probability that x is below 105, and that probability is 0.630559. So I'll go ahead and show that also on our normal distribution calculator by David Lane here that we looked up. Again, mean is 100, standard deviation is 15. Notice how it ticks off the mean in the middle, 1 standard deviation, 2 and 3 standard deviations above, 1, 2 and 3 standard deviations below. I want to calculate the the area below 105, and again it's giving me 0.6306. So same as Statcato, just rounded to one less decimal place. And this one shades the area. It's a little bit over half, and that makes sense. Recall that to get from an x value of 105 to a z-score, I need to take the x value of 105, subtract the mean, and divide by the standard deviation. And that's for a population. Of course, it's the same for a sample, but different notation. In this case, we have 105 minus the mean of 100 divided by the standard deviation of 15. The z-score is 1/3 or 0.33. That's what we would have to do if we were using a z-score chart here, or the standard the normal curve chart, and we would be going to 0.30123, and we get 0.6923, which is approximately 0.63. It's not as accurate using the chart, but it works all right, especially to the nearest hundredth place. If we were doing this in Statcato, we would be going to probability distributions, normal, our standard normal curve, because we would be using z-scores, would be 0 and 1. We'd be using cumulative probability, and we would be using, let's see if I can put 1/3 in here. Nope, I need to put 0.33. And compute, and it will tell me my probability of being below 0.33 is 0.692300. That's slightly less because it's rounded from the 1/3. Showing that on here, I would be using a mean of 0 and a standard deviation of 1. That's for z-scores. Now we've translated these into z-scores, and I would be doing the z-value, the probability of z-value was below 0.33. And again, I get 0.6923.